Hello and welcome to another LeetCode problem. Today we're going to be doing the problem of the day for the July 7th and is maximize the confusion of an exam. It seems that they really like giving us very similar problems in the last few days, but let's go over this one. So a teacher is writing a test with n true or false questions with T and F. He wants to confuse the students by maximizing the number of consecutive questions with the same answer. You're given a string answer key where answer key I is the original answer to that question. In addition, you're given an integer k, the maximum number of times you may perform the operation. Change the answer key for any question true or false, and return the maximum number of consecutive true or falses after changing it k times. So in the first example, we have a TTFF, and we're given two changes. So this one's pretty straightforward. We can either change the trues to falses or the falses to trues, and we would get 4 total, right? So let's say we just change these two to trues. We would use our two changes, and we would get 4. Okay, next example, we have a true, false, false, true. Once again, pretty straightforward. We can make one change. So we'd want to keep the F's connected, and so we'd want to change this T to an F, or the other one to an F. And then we would have 3. Okay, next one, we have T, T, F, T, T. That's a little hard to read there. Okay, and so we have one change here, and they are replacing this F right here, right? So you would replace this F with a T, and you would get 5 in a row. Okay, so let's actually break down this question, and I'm going to show you a really easy way to do it. You could try to go for the complicated way. I think you could do like a complicated optimized sliding window, but the complexity is going to be the same, so I think if we just break it down, it's going to be a lot easier. And so here's what we're going to do. We're actually going to look at this bottom example. So we have a T, we have a T, we have an F. And yeah, I believe like we had a problem we had a bunch of problems that were similar to this. Once I show you the way to break it down into an easier solution, it will all be clear to you. Okay, so we have this, and then we have one more thing. We have 1, k equals 1. So we can make one change. So what we can actually do is we can break this down to 2 problems. And our problems are going to be the same exact code. We're just going to look at the variable we're going to change. And so we're going to, in the first case, we're going to try to change all falses to trues and try to get the maximum biggest sequence of trues we can get. So we'll just call it max t. And then in the second case, we're going to try to change trues to falses and get the maximum sequence of falses. Then simply, we get a max of the 2 to get the answer. And so for trues, how are we going to do this? So we have k equals 1. So it's pretty straightforward. Once again, we're going to use a sliding window as in the last 5 problems. And we are going to just keep the track of, so here we are changing falses to trues. So for every false we encounter, we're going to increment some counter. We can actually, what we can do is we can set our counter to k. And then once counter is below 0, that means our sliding window is no longer invalid. Oh, sorry, is invalid. So we can change one false, but if we change more than one false, then we would have to fix our sliding window. So let's actually use another color for the sliding window. So we have one change we can make, and we're looking for every false to change to a true. So we're going to go here. This is fine. Here, this is fine. We encounter this false. Now our count goes to 0. Count of 0 is still fine. We just can't have a negative count, right? Negative count means we made too many changes. So we're going to keep going, keep going. Okay, we hit this false. Now this makes our count -1, and so this sliding window is no longer valid. And by the way, once again, as before, we are going to, at every single iteration, we can just, after we make the sliding window valid, we can just maximize the result as always, right? You just do like result equals maximum of result in the current sliding window, standard sliding window. Anyway, so our count is -1. Now we have to shrink our sliding window because our window is no longer valid. So the way we're going to do that is we're just going to keep deleting from the left until the count is back to 0. So we're going to delete all this, delete all this, delete all this, delete all this. And then once we delete this false, then our count is back to 0. And now this red is our sliding window that's left. So it's this TTF. Okay, so this green is all deleted, 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 deleted. And then this is our new sliding window. Now we keep going because our count is still 0. Keep going, keep going. And so the maximum sliding window we reached was either this one that was valid or this one that was valid. Okay, so now we get a count there. So we're going to get a count of 5, right? Because our maximum sliding window length is 5, this one, or this one, where we only made one change. So now we're going to delete this. and we are going to say the maximum of t was 5. Now we're doing the exact same thing for the false. We're going to try to maximize the falses. We have one change, so let's go. So here we already made one change. So now our count is 0. Remember, we are trying to have everything be a false, and we can only change one true to a false. So now we made 2 changes. Our count is no longer valid. So now we are going to be doing some deleting. Now our count is back to valid. We have one change. Now we're going to be adding, find, adding. Our count is -1. And then we have to shrink it again to make our sliding window valid. Now we have a valid window again. Now we're going to be, so this is a valid sliding window. Now we're going to add. This is 2 changes. Remember, we're trying to make everything falses, so -1. So we have to be deleting. Now we only have this one true element. Now we can add the false. That costs us nothing. Oh, by the way, this is back to 0. We add the true. So once we add a true, -1 again. So we need to be deleting. Make this 0. We add this true again. We can only change one true to a false, so we have 2. So this is -1, so we need to be doing deleting. And here, this is 0. Now we have a valid window. And so the maximum window we're going to return in this case is you can only change one true to a false, so the maximum sequence is going to be either this one, or this. They're all like the same, but this is going to give you a 2. Right? The maximum valid sequence we had was something like this or like this. These are all valid. And so here we're going to have a 2. Now, what's our maximum out of both these? It's a 5, and so our solution's 5. So that's literally all it is. That's all the explanation. You just go for the trues, then you go for the falses, and then you maximize it. You can try to make an algorithm where your sliding window contains both. It's going to be more confusing, and it's going to have the same complexity, so I'm not a huge fan of doing algorithms that have the same complexity and are just more confusing. I don't really see the point. Okay, so we are going to code up this algorithm. What we're going to do is we're going to make a helper function that's going to take a string, and then we're simply going to use one string for true, one string for false, so it's going to be the same code. We're just going to call that helper function twice. Okay, so it's literally just use, convert falses to trues, then convert trues to falses, and this is how many total changes we can make to make sure that your sliding window is still valid. So we're going to set the count equal to k, and then if our count is less than 0, we have an invalid sliding window, so then we got to do some work to make sure it's back to valid. As soon as the window is valid, then we're going to maximize the result. All right, so now we have enough to code it up. So we are going to say def, we can call the function confusion maybe, and it's going to take a true or a false value. We can just say maybe letter or something. Okay. And so we're going to have normal sliding window, so we're going to have a left. We are going to have a result. We are going to have a count. We're going to set it equal to k, this k right here. This is how many changes we can make. Now we are going to have a right for right in range, as I did in my previous few problems. So you can use the right. The right can be just in the range of your answer key. You don't actually need a left and a right. You can just use, because we're going to be traversing through this answer key, so your right can just be straight in the answer key. This is going to be the right side of the sliding window. Okay, and as always, what are we doing? So if our answer of the right does not equal the letter we want, like let's say we pass in true here. If we pass in true, if it's not true, then what are we doing? So if it's not the letter we want, then we have to make a change, right? And so if we have to make a change, like let's say we're trying to maximize our trues. If we get a false, that's one change, and so we have to decrement the count. And then when the count, so this means we have an invalid sliding window. While the count is less than 0, we have an invalid sliding window. And so if we have an invalid sliding window, we have to be moving the left up until it's valid. So let's do that. So if answer, this is literally the same code here, except it's left, right? So think about the same kind of thing, right? So let's say we're trying to maximize our trues. Here, every time we get a false, this would be true. Like if we pass in t, every time we get a false, the count would decrement, and then every time we get a false again, the count would increment because now we have less falses. Okay. And so now we're going to increase the count back up. And now, after this line, we have a valid sliding window. So now that we have a valid sliding window, we're going to try to maximize the result. So that's the same. Oh yeah, I forgot one more thing. We actually have to, when we subtract the left, we actually have to move the left, right? Like, we're going to subtract the left character, and in our window, like let's say we have a window like this, and we're subtracting from the left. Let's say we subtracted this character, we actually have to, the new left is actually here. So every time we subtract the left character, we actually have to move it up. Okay. We don't have to check if the left is less than or equal to right because key is at least 1 in this, and so the left will never surpass the right, because if you have one element, then the count will never be negative. Okay. And so now like I said, at this point we have a valid sliding window. This is gonna check to make sure our sliding window is, like, working. This while is gonna continue as long as our sliding window is invalid. Now that our sliding window is valid, what are we doing? We're just maximizing the result. And as always, to get the length of the sliding window, it's right minus left plus 1. Good thing to remember. Right, so like if your right is 3 and your left is 0, the number of elements you have is 4, so 3 minus 0 plus 1. Now we return the result. And now we simply have to call this confusion function. So we're actually going to return the maximum of this confusion function on what letters are we trying to use. So we're going to try to make everything t's, and then we're going to try to make everything falses. And that's pretty much it. We're going to call confusion with t's, change as many falses to t's as we can, get a maximum there, call confusion on false, change as many t's to falses as we can, get a max there, and the maximum number here is going to be our result. And so let's see if that works. Okay, looks good. Okay, it's a pretty efficient algorithm. And let's think of the time and space. So like I said, you can make a sliding window, I believe, I haven't tried it, that you could refactor this confusion to be one function that keeps in track of the left and the right, but I kind of don't see a point because you're not going to get a better than O of n complexity. And so I just think there's like better things to do than, yeah. But I mean, if you want to do it, go ahead. Okay, so anyway, so the time here is going to be, so this confusion is one sliding window, so that's going to be O of n, and we're just calling it twice, so it's going to be O of 2n, essentially. And like the reason I made a helper function is because the code for the true and the false is literally all the same. I just need to pass in a letter. So that definitely is good practice. Like you wouldn't want to have this code same thing twice, but up to you. Okay. And so, I mean, yeah, maybe if you were doing like a actual, like in a coding interview, this is definitely way better. But if you were doing a like a contest or something, then maybe it's better to just copy your code twice and write in a letter just to make it easier to follow. And you don't really care about like reusability and things like that. Okay. And so for space, we didn't actually make any extra variables. So we just used, or we did make variables, but we didn't actually allocate any extra space. So just a normal sliding window is going to be of 1. All right, and that's actually going to be it for this problem. Another pretty simple one, another sliding window one. I think we have like 3 or 4 in a row, so hopefully we don't get another sliding window one in the future. But that's going to be it for this problem. So if you liked the video, please like the video and subscribe to the channel, and I will see you in the next one. Thanks for watching.